Okay, we're going to continue talking in section D. A global maximum is also called an absolute maximum. It names the largest range value over the entire domain. A local maximum, also called a relative maximum, gives the largest range value in a specified interval. An endpoint maximum can occur at an endpoint of the domain. All these same things hold true for minimums. So you can have a global minimum, a local minimum, and an endpoint minimum. Here's an example. We're going to go evaluate a function. First thing is we're going to find the domain and the range. The domain is all of the x values, x such that x is going to represent all real numbers. Probably the best way to do this is in terms of interval notation. It goes all the way from negative infinity to positive infinity. The range is all of the y values such that they're in a set. The lowest absolute y value is at -4, and it goes at everything above that. So it's -4 all the way to infinity. The intervals where it's increasing or decreasing, we're going to start with the reading it left to right. So we're going to start with going with decreasing. So f of x goes down. It starts here. Its highest point at negative infinity, going from the x direction all the way until it hits the point at which it changes direction, and that happens at -3. It also decreases all the way from the point at x equals 2 all the way to 5. So if you're looking at the function values of where it's decreasing, f of x is going down from the x values all the way from negative infinity up to the point where it changes direction at -3, and also from the values from 2 all the way to 5. If we look again at where it's increasing, it's in between the values from x equals -3 all the way to the point where it changes direction at x equals 2. And it also happens from the point of x equals 5 to infinity. So f of x is increasing for all of the x values. Remember, going from -3 all the way to 2. And then the last section of the graph, when it hit at x equals 5, so everything on its right to positive infinity. Max and min values happen when they hit a high point or a low point. So if we're looking at points at which the graph hits a high point, the maximum here in the middle is going to hit at that point 2, -1. That is a local max. There is no global max because this graph will continuously increase on the ends. The end behavior is up, up, so it does not have any maximum point overall. If you're looking for minimums, we're looking at points that are hitting at a low point. So we have local minimums happen at this point here at -3, -4. And there's also a local minimum here at 5, -2. And if we notice here that this point, -3, -4, also happens to be the lowest point of the entire graph, which means it is called also a global minimum. Intervals where the function is greater than or equal to 0. We're looking for the values of the function where the y values are equal to the x-axis or above. That happens from over here and above, at this point and above. So you have to find those x-intercepts. So our function is greater than or equal to 0 for the x values from negative infinity all the way to this point, including this point because it's equal to it, at -5. So you have to put the closed bracket to include it. And then from this intersection point on the x-axis where it's equal to it, and everything above it is to its right. So it goes from the positive value of 7 to infinity. The opposite of that is when everything is below the x-axis, when it's less than or equals 0. It happens all the way in between those points of -5 to 7, and not including them because that would be when it's equal to, and we just want when it's less than. So those from the values of x from -5 up to +7, not including either one. Whether the function is even, odd, or neither, you want to determine if it's symmetrical over the y-axis, which this one is not, so it's not even. You want to see if it has a pivot point around 0, and if it's symmetrical over the origin, it is not, so that means it is neither even or an odd function.